Okay, are you on? Yep. Okay, I'm going to do testing of an installation, top to bottom. When you do testing of an installation, you've got a test chart. AS3000 goes through the mandatory tests. So I'm just going to look at this there, Dobbo. Continuity of the earthing system, insulation resistance, polarity, correct circuit connections. I'll do that in another video. That for this particular crowd, you won't have to do correct circuit connections, but I'll do that in another video. Verification of fault loop impedance, you have to do that, and operation of RCDs. Why can't we do that test? Neon? There's no power on. Continuity of the earthing system, as far as the rule book goes, this is important, Mitch, that there's a bit of information about the earthing system, and then there is results, the results that you need to get. So when you do the earthing system, look at the results. When IR, this bit here talks about IR, and then it gives you the results that you've got to get, so on and so forth. So on and so forth. Right? Okay, so what are we going to start with on your charts? What's the first thing? What's that?
Resistance of earth.
Okay, continuity of the main earth. So here I've got my mega. I'm going to start on 0 ohms, on battery check, make sure my battery's good. Flicker over to 3 ohm scale. Now I'm a bit below 0 there, which is no good. So I have to zone that up to 0. If you don't know about the second part of your mega, on 500 volts, when you go together like so, see how I'm a bit below 0 there, Dobbo? This sucker here is like your 0 adjust to get 0 mega ohms on 0 mega ohms. A screwdriver would be a bit more handy than my fingernails. Oh, see that there, Dobbo? See that move there? See now 0 mega ohms on 0 mega ohms. Right, it's very important. Come on, Tara, it's important. Okay, I'm going to test the continuity of the main earthing conductor. From the disconnected end of the MEN link here. Sometimes I'll go to here, sometimes I'll go to here. Is there a visual fault there, anyone? Can anyone see a visual fault?
Soldered.
Soldered and under a screw. That's not really what we're here for, but just, an extra point. Okay, from 0, from the disconnected end of the main earth, let's see that we're good here. I'm on 0. Over to where? Do I go to the conductor or to the stake? Stake. Stake. To the stake. Now look here, Dobbo, have we seen anything move there? On the, no, I have not. So what should I do there? Is that infinite? Move on?
Next scale.
Next scale, Matt, well done. Oh, well done. Now, on the 500 scale, I'm looking at 15 ohms. So I'm going to pop that down on the main earth. Pop that down on your chart here. Main earth conductor. Record instruments, readings in units. You write down, what was it, 15? Now, Ryan said before, can he just go through the pass the files, can you do them later? Yes, you can. You're obviously going to have to know the results, the acceptable results, to be able to indicate to pass the file. You can go through and get all your readings and then sit down later on and write down if it passes the files. Don't care. Just do whatever works for you. Here, what's the next bit? Has anyone got testing charts here, apart from Smitty? What do I got to do now, Smitty?
Water pipe.
I'm always going back to 3 ohm. I just like to start at 3 ohms. Bonded parts?
Yeah.
Meter, Dobbo? See my meter there? What am I reading on my meter? I'm reading on my meter on the 3 ohm scale. I'm reading like 0.2 of an ohm. 0.2 of an ohm, I'll pop that down. That would be a pass or fail for anyone that knows.
Pass.
Pass. What's the acceptable reading?
0.5.
Moving on. Next test is insulation resistance of wiring. I've got to do a whole insulation resistance test. Now I've got to test the final sub-circuits. Now, one thing that you want to check is, I'm just going to set this up, I should have set it up before. The switches are off, right? If so, am I here to test an appliance in a whole insulation resistance test? No. I'm just here to test the wiring, aren't I? So I've got to make sure it's out. Do I not? Mm-hmm. Yes? If there was a fault, Makush, in between this switch here, if there was an active to earth fault in between this switch here and the actual fluoro, and the switch was turned off, would I pick it up? So therefore, it would be fair to say I've got to turn it all on. So I've got to turn all these on. Now while I'm at turning things on, I may as well just turn everything on. In the unlikely event that there would be a active to earth fault after this switch, very unlikely there would be, but let's just turn everything on. Happy with that? She's all going on. Now, another thing to consider. If there was an earth nail through up here in between this line consumer's mains and the fuse mains box, if these are not joined up, would it pick it up?
No.
No. I need to join these up. So my whole installation consists of, Brad, from the point of supply to the board and then the whole installation. So therefore I need to join my actives up. Now, later on, someone feel free to remind me, I'm going to have to measure the resistance of this when I go to do polarity for a few things, but for now, it doesn't matter. What's insulation resistance mean? What have I got to test for? Between what and what? Live parts and earth. So that would indicate that I have to join what? Live parts. I can do that anywhere. I can do that up here, do it here. I'm just going to do it here because I just like to do it here. You could theoretically do it here. I don't know why I don't like to do it there, I just don't. I'm going to join up neutral here. I'm going to join up to the active there. So now I'm a live parts connected, jump. Yep, go, Ryan. Yep, okay. Now all my switches here are on. If I want to do a whole installation resist test, should I have all my breakers on or off? Everything on, I've got to join it all up. All RCDs, all breakers on. Now let's just double check this. Think about this. Is everything joined up? Are live parts joined up? Yes. Are consumers mains, actives joined up? Yes. Are all breakers and all circuits on yet? Yes. Are all switches on? Yes. Can I proceed? $500. I'm always keen on double checking to make sure 0, 0. You see over here, Dobbo, there's 0 and there's 0.01. There's very small difference between 0 and 0.01. So the only way you'd be able to tell was if you like kept on zeroing your leads out. So I'm going to go in between here because I don't want to give myself a shock. Between here, everything's on. And does it matter if I go in between active or neutral? Doesn't. Why not? Because they're all joined up. Okay. My reading there is a 0 megohms. Dead short. 0 megohms. Now I'm led to believe, rightly or wrongly, that I don't think there's any like 0 readings and infinite readings. I think there's always a reading. But I don't actually know that. That's just hearsay. So I'd write down 0 megohms. What's the reading got to be?
Above 1.
Above 1. Okay. Now, we've got that down. Next, what am I going to do? You tell me.
Individual circuits.
Turn all breakers off, because now I can do individual circuits, can't I? Okay. So I no longer need this link in here, because I'm going to do individual circuits, and I happen to need that link. So I've got everything off. So over here, let's get that out of the way. I'm going to drop this in on the active of the circuit under test. Now in this case, in my case here, I need to get that neutral out, so I know that I've got it. In your case, you'll be able to just pull it out. I don't believe that you need screwdrivers. I think that it's easily accessible. So I need to get the neutral that belongs to that circuit there, so I can test it. So it's not in relationship to the others, as Mitch Turner very nicely pointed out, apprentice of the century. Now, I'm going to join up active and neutral here, yes? So I joined up live parts for that final sub-circuit jump. 500 volts on in between earth and that. Seems like it's an open circuit, doesn't it? That didn't move one bit. I'm going to touch them together just to make sure my meter's still moving. Yep, go in here. Circuit seems good. That circuit's good. That was infinite. What am I going to do next? Next circuit. What's it say on your testing chart? Circuit 1, circuit 2, circuit 3, circuit 4?
Yep.
Simple as that. You'll do whatever it tells you to do. I'm just going to can't really nip that up too hard. Someone else is going to manipulate that in a minute. Circuit 2, what have I got here?
RCD.
MCB RCD or just straight up RCD? It is an MCB RCD. So the final sub-circuit, we're trying to get the point, Madeline, that the final sub-circuit terminates to there. That's the thing that I'm on the test. Are all my switches on? Let's just double check. I need to make sure they are. 500 in between here, between live parts and earth. Seems like that's good as well. I should have more IR faults in here. I'll just place it in me. Okay, 0, so I'll write that down. Next, take that out there. Now here, I've got an RCD controlling 2 breakers. So here I've got an MCB RCD, here I've got an RCD controlling 2 breakers. So I need to pick one circuit, here, just the actual circuit, not at the RCD, I need to pick the circuit. I'm turned off. So really, I need to now find the neutral. I don't need that. I need to find the, Billy, pause. You got good ones? Yeah. I need to find the neutral for that circuit. Just so I'm not getting anything from any other circuit. Okay, joined up live parts. Mega. I know, you see these ones here? I'm told that it's like this, that you can just pull them out, so you can actually pull the neutrals out to deal with them for their final sub-circuit. You have to use your mouse, so as far as cable size goes. You know, like what, I can see that's a 2.5, so I sort of have to follow it round to make sure I've got the right neutral. I've joined live parts, 500, am I on? Yes, I'm on. Between here and here. Oh, seems like I'm down. So there we go. I'm looking at 0.6 of an ohm there. I'll just touch this on here. 0.6 of an ohm there, yep. So 0.6 of an ohm. Is that a pass or fail?
Fail.
We happy with that? 0.6. It's not greater than 1 meg ohm. Big fat fail. Okay, between my active here and my neutral of my lighting circuit, touch myself together here. Here and here. Oh, and I'm right down for a dead short there, okay? Now, Dobbo, just as an investigation here, just flick those light switches off there, down there. Just flick them off. And all of them. Oh, now see that? That fan one there. Flick that fan back and forwards. Isn't that interesting? So if you didn't have that switch turned on, for those of you who are a bit far back, as Dobbo's flicking the switch, it's going fault, clear, fault, clear, fault, clear. So you'd have to be making sure, wouldn't you, that... Okay. Disconnect that there. Just stop for a second, Dobbo, while I twist these together to save that memory. Okay, we're happy that we've done... are you on?
Yes.
We're happy we've done installation resistance of the whole installation, the final sub-circuits. Geordie? Done this. Over the page. IR of the appliance. Now you get an appliance. Who knows what it could be? Could be a, I don't know, could be a fan, could be a 3-phase motor, you know, could be whatever. Are you having fun with my nose though, right? I know it's big.
Well, actually not. I'm not, I promise.
You don't have to go up close as well. You've got a zoom, you know. Come on, Dobbo.
Okay,
now,
if you want, mate.
Dobbo, this is serious stuff, Dobbo.
Righto.
It's your exam.
Yep.
Now,
Start again.
I can't remember where I am. Installation of appliance, and this is an appliance. Now, what do we know about, what's the only exception for installation resistance? Sheath heating element.
What's it? Point?
Sheath heating
It
element.
is recording.
Okay. And what's the requirement for a sheath heating element?
0.01 is it?
Of a watt. Okay. Okay. I'm doing earth continuity. I'm on the 3 ohm scale there, Dobbo, just so we we've got full scale deflection there. Okay, how do I do this? In between the earth pin and what? Yep. What have I got?
Nothing.
Ooh, imagine that. Imagine if we forgot to do that. That'd be a killer, wouldn't it? 'Cause yeah, if you've got to go up to 500. So what's our recording reading?
5.
Yeah, something like that. 5. Yeah, 5. That'll do. Okay, make sure you get a good point of contact. Now IR over to 500. Now there's a couple of ways to do
You're
this.
on 250, one more.
Sorry, thank you. I'm down low. Yeah. Okay, here I'm just going to go like this personally. I'm just going to join them up like that. You can get a clamp, clip. Just going to touch this together to make sure I've got full scale deflection there. I have. Okay, in between live parts and earth, I can go to here or to here. Anything happening there, Dobbo?
Got nothing happening there.
No. So is that clear? Is that? Oh, now look at that. I didn't have the switch turned on. Let's turn the switch on. Is it moving?
0.
0. Now, what you'd have to be careful of here would be that if it's a sheath heating element, the difference between 0 and 0.01 is very small. So you'd have to make sure, you'd have to be going from here, Bill, to touch them together to make sure that 0 is 0, and then seeing if when you go to there, if it's actually any different. And then the switch is on. If there's a fault, obviously with the switch off, it's just a dead short. It's a fail no matter what, isn't it? Next test. Resistance of protective earthing conductors. Yep. What's that, Ron?
That's all right.
No, you got something? What? he wanted to ask, but he was scared. Dobbo's done that anyway. So now, what's your question?
Nah, I forgot.
Okay.
Ask you later.
Okay. Protective earthing conductors, 0 scale. What have I got to do here? What's it start with? Over here it says ceiling rows. Ceiling rows, 1.5, 1.5, 10. It gives us the RPH, active conductor resistance.
0.5.
Fluorescent 0.5. This is out of, what table is this out of, anyone? 8.2. In this case, Bill, do I really, like, it's nice that they give us that, but we're not really here to test the pH, the phase value. We're here to test the earth. But we need to know that because we're going to have to add some stuff up.
Did you want to show the table?
Yep. So table 8.2 over here. Table 8.2, we're going to get our values out of here. I'll reference this back in a second. Right, table 8.2. Okay, so protective earthing conductors, I've already zeroed this out. In between the earth bar and what's my first one I've got to do? Ceiling rows. Over here, it's very low. I'm at like 0.05. 0.05, so we can get that down. Next one. Fluoro, was it?
Yep.
Now, it hasn't moved there one bit, Dobbo. So flick that scale over to 500 for me. Oh, imagine that. Imagine if you forgot to do that. There's 4 ohms on that fluoro. Obviously very important to flick the scale. Yes?
Yep.
Back to 3 ohms. Someone's writing these down in the spots, I imagine. Next thing I've got to test is socket outlet 1. In between here, I don't know what socket outlet is what.
I think it's there.
One's down the bottom.
Ooh. I'm on the 3 ohm scale, so that's like pretty much 0. And socket outlet 2, over here, this one will do that. Flick on to 500 for me, Dobbo. Thank you.
We've got 20, is it?
Yeah, 21, something like that. Okay, so I've got them down. Now, when you had those readings down, I think I had these down here like this. What was the first one, someone? 0.05. And the next one was 4. Okay, so as an example here. RE values, RPH values. RPH value in unit calculated. Add that plus that. So over here, I'm looking at 0.95. indicate if this is a pass or fail. I go over here and go, I'm dealing with a 1 mil cable, 1.5, 1.5, 10. 1.5, 1.5, 10. I slip over here, type C breaker, RPHE 1.96, I've got to be less than that. RPH 0.98, RE 0.98. Over here, is it a pass or fail? It's a pass. And if you want to make a note for yourself, it's got to be less than 1.98. Was it? Or 6? 6.
And all three of those values have to pass the pass.
Yeah, now that's correct, Ryan, but you would think about it. I don't believe, and again, I don't know, Ryan, that I think you'd be being chucked under the bus in a major way if they gave you a bad RPH value.
15 minutes ago.
You know what I mean? They should, the RPH value should be okay. Because you're here to test the resistance of the earth. Next. Polarity of consumers' mains. Let's check that. 3 ohms. What's the result say there? What does the result say as far as polarity of consumers' mains in 3000?
So it has to be a connection to 0.
It has to be a connection. Does it give us any resistance reading? No, it does not give us any resistance reading. So hypothetically, if I had 2 ohms on the active and 5 ohms on the neutral, does that test a fail?
No.
In life, real life, would you be investigating that? Certainly. For the sake of this test, it just has to be continuous. Okay, on the 3 ohm scale over here, have I got my actives joined up?
Yes.
Again, providing that that's good in between there, that lead there's good. I don't really care about the reading of that, like this lead. If you want to zero the lead out completely, then you could zero it out. I don't care about it because I'm not here to test fine ohms, I'm here to test if there's a connection. My connection, Sam, goes from the active here to here, over to my main switch, and I've got a connection, it's good.
Yep.
The neutral, I go from the neutral in case you don't know, in case you're not a domestic guy, the neutral from here goes from here to here, out of here, over to the neutral bar. So I'm going to go from the neutral bar to the neutral, and it's good. So I write that down. In this case, it's like 0.01 and 0.01, whatever it is, pass and pass. Next test. Operation of switches. Now this is probably the trickiest one, I would say. This is the trickiest one. I've got to make sure what the test is saying. Is the active switched? Or is the neutral switched? Or is neither switched? Now what would cause the neutral to be switched over here? That's a switching terminal. Someone's like mucked it up. Someone's been, not concentrating, whatever reason, when they fit it off and they put active and neutral. So that's the only switch terminal in the socket outlet. We happy to say that? What about a lighting circuit? We're in a lighting circuit. Could someone switch the neutral up there? They could. Someone could actually switch the neutral. So what I'm trying to say to you, Ryan, is this is the only terminal you have to check for a socket outlet. And over here, if the active isn't switched, then you better check if the neutral's switched. But I'll do it for you. Okay?
You better off doing it.
Well, if the active is switched, then you can move on. I'm going to leave the main switch off. I don't care about that. Everything else is going on. Because for me, I don't care about circuits at this point. I just want to make sure that what I'm dealing with is switched. So the important bit here is I'll go in between the active terminal here. And I'm just going to go, if you think about it here, I'm just going to go on the load side of the main switch. Anything wrong with that? Because it's all linked up, all my actives are linked up. So I'm happy with that. I'm flicking my switch over here at the socket outlet, and it's switched. So we're happy with that. Socket outlet 1 active is switched. I'll just go through them all. Socket outlet 2 is the active switch, yes. socket outlet 3. Oh, now I just want to show people what happened then. Between here and here. Oh, no, it didn't go. Well, the RCD went before, but anyway, that active switch there, that's good news. Things looking sharp so far. Over here, whoa, the active is not switched. Bad. Alright. So what am I going to do now then? I'll go to the neutral bar. Now, can I go up here? I can go up here, can't I? I can do that. Why? Because all the breakers are turned on. I don't care about which circuit it's on. Just need to know that the neutrals all flow back to here. Look, the neutral switched. Okay, so I'm in this terminal here, but up here I'm on the neutral bar, so the neutral switched. Bad news. Yes? Okay, lighting circuits over here. I'll go to the ceiling rows.
Bottom right.
I need an extra set of hands here. I'll just put that up there. Oh, that's in there. Ceiling rows. Oh, semi-jump then. Okay, now, is that a bad thing? I don't really think that's a bad thing. It's just taken the RCD out. So now I know that it must be somewhere over here. I'll leave the RCD off and I'll follow my nose around here. See, that's a bad connection there. Just tighten that in there. Someone's pull that out. So what I'm going to do here is I'm going to go, I'll make sure I've got a connection there, in between active and ceiling rows, and it's switched. Now all I'm saying to you is if that wasn't switched, let's say that wasn't switched, that was solid, what you'd have to do is, you'd have to go over to the neutral and then go to the neutral for that circuit and see if that was switched. You know what I mean?
To do that.
You have to separate the neutrals from that, wouldn't you? Like I did before.
Well, no,
No?
I don't care. Is the neutral switched or is the active switched? I don't care about the circuits.
Do that.
Okay, over here I'll check the fluoro between active and, I'll just turn this back on again, active and active. Hit the fluoro switch, Dobbo. It's taken the RCD out, so I'll go back over here, it's on that one. Is the fluoro switched? Now that's the active. Now let's just check, so that's fine. What would I do if it was a neutral? I'd have to go to the neutral up here and go to the neutral of the final sub-circuit and flick the switch. Fluoro, yeah. Well, once you've established that one switches, it's fine. And over here on the last one here, I'll muck that one up later. Between active, I'll go over here. Yep, that RCD will probably go. No, it didn't. Active is switched. Okay. If I wanted to check the neutral, I'd go to the neutral terminal, to the neutral bar. Yes. No. Now, once you've established that one switched and not the other, then you're fine. You can move on. How long have I got to go, Dobbo? Am I going to have to stop it and download it?
8 minutes.
8 minutes. I'll nail it. Okay. So I'd write this all down. Indicate the conductor is being switched, active, neutral, either. If pass or fail, there we go. Now, as far as the results for that go, it's relatively important. Results. Proof that all active, neutral and protective earthing conductors in the electrical installation are correctly connected to the corresponding terminals. Does active go to active? Does neutral go to neutral? Does earth go to earth? Now, they probably give you a bit of a chop out here and say you don't have to test the whole thing. We've already tested the earth, haven't we? So that's done. And if we prove that the active is switched, then well, where else is the neutral going to go? Switches to protective devices don't operate in the neutral. All Edison screws, the skirt has to be in the neutral, and all fixed multi-phase to be connected, so the phase sequence. Phase sequence, we're not talking about multi-phase. Okay, are we almost done here? We're just down to testing for the circuit for automatic disconnection of supply, which is what? fault loop impedance. Earth fault loop impedance. Now, let's quickly do this before we run out of juice. What am I testing for when I test for earth fault loop impedance? Elliot said that the resistance is low enough on the phase and on the earth that would permit the protective device to operate in the event of a fault. Is that what you said? And when do you have to test for fault loop impedance? On circuits that are not protected by an RCD. That's why Matt's got like 89% in theory. So, circuits that are not protected by an RCD. In this case, I know that this breaker here controls this circuit here. If you didn't know, how would you find out? If you didn't know what was what, tell me, would this do it, Madeline? If you went in between here and here, would that tell you if that's... That'd tell you, wouldn't it? Okay. So what we have to do is, I think I've spoken about this at length with people. If there was a fault on the earth, a high resistance earth, then it would permit current flowing, wouldn't it? If there was a fault down on that. So that's typically a stove, isn't it? Active earth fault, if there is resistance on the earth, inhibits the current flow, the protective device might not go out. And the same can be said for the active. If there's a resistance on the active, and down at the oven, something's plugged into that, there's an active to earth fault, it'll permit the current flow. So therefore, you've got some touch voltage on the frame. But that's background. Here, I'm going to join up the active and the neutral, active and the earth. Now, have I forgot to do anything at this point? I've just caught myself. Thank you. I'm testing the active earth loop. So therefore, I need to make sure that the resistance of this lead is taken out of the equation. Now you see at Dobbo how we're not quite at zero anymore? So I better just change that. And what I'm doing is I'm zeroing out the leads. I'm zeroing out the leads. So when I put this back on over here, I've allowed for the resistance of the lead. So if I go over here, that's going to be slightly above zero. Oh no, slightly below because it's got to come up.
Yep.
Okay? So I'm testing the active to earth loop. So I've got a connection up here, haven't I, Rossi? So therefore, if I get down here and go active to earth, turn the switch on, that is going to tell me my reading.
0.05 is it?
0.05. Yep, I'm happy with that. So then I'll go over to table 8.2 and I'll go, I'm dealing with a 2.5 and a 2.5, is it a 16 or a 20 amp breaker? It's a 20. 2.5, 2.5, 20, and I fly over here and my reading has to be less than RPHE on a type C circuit breaker. Make sure that you check the type of breakers. I assume you're going to get a type C, but what happens if they don't? That would muck your reading up. That'd be a good way to stumble some people up that don't know how to test. Lucky you know how to test. 0.98. So I'll be going here, type C circuit breaker rating, 20, measured values and units. What did I measure? 0.05 of an ohm. RPH values from 8.2, what was it? 2.4, 20, 0.98. Ohms, pass or fail, pass. Worst writing in history. And we're sorted. It's testing. How many minutes have I got left, Dobbo?
2.
I don't need to do that RCD one, do I? Okay. Anyone got any questions? I don't. That's it.